Dosage problems are an example of unit analysis. The first question to ask yourself is what units the answer should have. And for part A, they're asking for milligrams. We look to see where else there are milligrams in the problem, and it's up here. 150 milligrams per kilogram per day. For ease of calculations, you can ignore the per day part till you go back to answer the final question. So write down the number with your units, 150 milligrams per kilogram. So we have the milligrams where we want them, but we also have kilograms which we don't want. Where do we have kilograms? Well, nowhere. But we do have pounds, and we know that pounds measure the same thing as kilograms. So to convert between pounds and kilograms, you'd be given the conversion factor on the test. You'd be told that 1 kilogram is 2.2 pounds. And putting it like that, you can make the kilograms cancel out. But now we have pounds, which we don't want. But we know that the infant is 22 pounds. And when we multiply by that, the pounds cancel out. When we multiply all this together, we get 1,500, and the only unit left is the milligrams. Now it's asking how many milligrams per dose, and it says that there's a dose every 4 hours. That's 6 times a day, so you divide by 6. And 1,500 milligrams divided by 6 is 250 milligrams per dose. Now the next part, they're asking how many milliliters of the liquid that the infant receives per dose. So again, ask yourself, what unit do they want for the answer? They want milliliters. Where do we have milliliters in the problem? Up here where it says 0.5 grams per milliliter. The problem here is that if we wrote this as a fraction, milliliters would be in the denominator, and we need it in the numerator. But remember, unlike in other cases, here it's okay to flip your fractions upside down, and we can write 5 milliliters over 0.5 grams. Now, what do we have that can cancel out with grams? We don't have grams anywhere else in the problem, but we do have milligrams. And hopefully you recall that there are 1,000 milligrams in a gram. So let's put the 250 milligrams here, and then we can write the relationship between grams and milligrams so that the grams will cancel out. There are 1,000 milligrams in 1 gram, and writing it like this, the grams and the milligrams both cancel out. So the only unit left is milliliters, and when we multiply all these fractions together, we get 2.5 milliliters in 1 dose.